Hello, so welcome to today's webinar for AWS entitled Managing Your Cloud Assets. My name's Ryan Shuttleworth and I'm a technical evangelist at AWS, and it's my job to speak to as many people as possible and talk about how AWS Cloud can be used, the benefits it can bring you, and some of the more finer technical details of how to get going with it. And today's topic is all about understanding two frameworks within AWS, the Elastic Beanstalk and CloudFormation. So today's agenda is going to really fall into four parts. First bit I'm going to do is setting the scene. So a spectrum of system definition and control, I've called it. Two polarized ways in which you might go about looking at managing your environment, or two different approaches or philosophies you might have inside your business. And then we'll look at a shrink-wrapped approach to managing your systems in the AWS cloud using the Elastic Beanstalk. And at the opposite end of that spectrum, fine-grained control using CloudFormation. And then we'll look at how these two systems can be used together in complementary uses. And we'll drop a couple of customer examples along the way to give you some flavors of how they're used. So also, your feedback is important, so tell us via questions and answers or use the contact us form on the website what's good in these webinars, what's not, what you'd like to see next time, and indeed what you'd like to see AWS deliver in terms of products and features. We want to know what you think about what we do, and we're trying to react as best as possible to the customer requests that we get. So let's get into the meat and bones of this webinar today. So I guess the first thing to talk around really is the fact that cloud assets are growing quite quickly. So people have more defined architectural patterns, and indeed you can go to aws.amazon.com/architecture and look at the model architecture patterns that we put up there to describe different types of applications, such as web processing, batch processing, approaches to high fault tolerance and high availability. As a result of more understanding around the use of cloud resources, more applications are being put up there, more data is resident in the cloud, and more services generally are being created leveraging the cloud platforms. And what that sort of results in, the fact is that there are more and more cloud assets, and because cloud creates a greater agility within engineering and development and operations teams, the environments up there tend to be faster moving. So the problems associated with traditional change management, system infrastructure control and definition become slightly more pronounced. So looking at that, how do we maintain control over what is deployed in the cloud? And the two ends of the spectrum, as I spoke before. So a rather polarized view of the world is that at one end you'd have what I would call controlled chaos, and at the other end of the spectrum, meticulous management. So let's sort of give some typified examples of what I mean by each of those. So the controlled chaos end of the spectrum, you might have a process where we prototype an application, we deploy it to an instance in the cloud. We might iterate over that application using test and development cycles, and then we'd go into production. And we're doing this all the way through developing the application really, and you get to the point where you have to deploy on more instances for scalability. You might deploy onto a relational database service for scale of the application database, adding load balancers, auto-scaling groups, and then you sort of take a step back and say, well, audit what we have, how do we document what we've got? And it quickly becomes a DevOps sort of nightmare scenario, in that you might have a developer-centric team that's pushing a product very quickly to market, and the operational caretaking, if you like, doesn't happen in sync with that engineering cycle. And you end up with the question of, well, what do we have? Highly manual processes to get you to that point. So this works for a lot of people, but it has a different sort of set of dynamics to it, as opposed to what I call meticulous management, where we prototype an app, we plan the infrastructure around that prototype, we might implement build standards for that application, deploy environments such as our test, our pre-production and so on, manage the deployment and the change of the application through change control, and we're implementing formal processes, often formal tools, and embedding configurations into software frameworks such as Chef and Puppet. Now this is a tightly controlled approach and at the opposite end of the spectrum to the previous example, but it requires quite a lot of engineering, a lot of effort to achieve that sort of control. So how do you get between these two things, and what are the key elements really that that allow you to move along this spectrum, or to find a place on that spectrum that works for you? There's obviously people. Your people are the key asset you have in implementing the processes or the controls that you might want to put in your environment, whether you have informal or formal processes, loose or tight controls. But fundamentally, you'll be wanting to look at implementing tools, and the cloud gives you the ability to achieve a great deal of automation. And the sorts of tools that you apply to automation would sit at either end of the spectrum depending on where you come from. So let's look at that sort of aspect of where you might come from. So if you're in a controlled chaos in sort of end of the spectrum, you might be looking to achieve some high-level shrink-trapped environments. You might have a developer-centric organization that just wants the application to run, and it doesn't really care about the infrastructure below, and only wants access to that if they really need to. So somewhere you can drop an application and have something that is a production-ready system, that you know that all the common problems associated with managing, controlling, and setting up an environment are taken care of. At the other end, you'll be looking for fine-grained declarative control, a meticulous planning sort of scenario here, where essentially you might have a DevOps or an operations team that's looking to source control, if you like, their entire data center. Just as they would source control configurations for, let's say, an Apache web server or an application server config. You want to source control, in effect, everything to do with the deployment of servers, operating systems, load balancers, DNS, etc., etc. And the tools that we have in AWS try to address these two different perspectives. So on the left, we have Elastic Beanstalk, which is really a drop and run environment for your applications. And on the right, we have CloudFormation, which deals with the detailed, fine-grained, declarative definition of resources within the AWS cloud. And I'm going to take a look at these two systems in turn, starting with Elastic Beanstalk. So Elastic Beanstalk is all about managing the problem of application versions and application environments, and trying to abstract the developer away from the need to maintain and create resources in AWS. So shown in this diagram here, I've got application versions at the left as the yellow boxes deployed into an environment, such as a test environment here. And a test environment differs from a production environment in terms of the types of application instances that are running, in terms of the size, the scaling that's going on. Here, test environment has an auto scale of a maximum 2. There'll only ever be 2 servers, whereas production has a minimum of 3 and a maximum of 6. In our test environment, it's in a single availability zone within AWS. And in production, it's in a multi-AZ, and it connects to different databases. So Beanstalk is about abstracting away the definition of those environments on the right and giving a framework for the deployment of differing application versions into containers that run inside those application environments. And those containers that we support with Beanstalk are important because obviously the languages you write applications in, .NET, Java, PHP and Python, are currently supported in the Beanstalk framework. So if you're writing applications in those languages, you can leverage Beanstalk today without any change to your applications. You can keep up to date on new containers. So we're adding new containers to the service all the time. So if you take an RSS feed from http aws.typepad.com, as we release new containers, you'll see sort of detailed blog posts come into your inbox regarding the functionality that we provide. So recently we added Python to that list, and Python adds a whole number of frameworks to support there, such as Django and Flask, in addition to the straightforward PHP and Java and .NET that we supported already. So the idea being is that you can take a standard web application package and put it into a Beanstalk. Now, what is happening underneath the covers? So your user application sits in an application container or application service, and underneath there we deploy onto those instances HTTP and language interpreters. So if this is a PHP container, we will be pushing out an Apache web server and PHP libraries. And then we're installing that onto an operating system, and you can choose when you start a Beanstalk whether you want 32-bit or 64-bit Linux, for example. If you're deploying a .NET application, this will obviously be a Windows server. And then we deploy that onto an EC2 host. So that whole stack is created and managed for you as part of the Beanstalk. And when you deploy into a Beanstalk, we not only deploy your application into a container, but we take care of the following. So we add elastic load balancers for you. So we'll create a load balancer in front of your application. We will add auto scaling group so that you can define the automatic elastic scaling of the application servers that are sitting behind the load balancer. And we will deploy instances with that fully managed stack running your application behind that load balancer. And we'll wire all of that into the Beanstalk framework and publish your application under a CNAME, a DNS name, so a URL that you can hit your application on. And depending upon the container, various different aspects of databases come into this as well. For example, with a Python Django app, we'll automatically create the RDS resources behind the scenes as well. So with one click or one drop of an application into a Beanstalk, you're creating a best practice template for the deployment of a web application in this case. Additionally, Beanstalk collects logs from these applications, the Apache logs, the application Tomcat logs, for example, in the case of Java, pulls them all together into S3 and lets you access all of that through the console, the AWS management console. And we also manage application versions. So if you upload a new version of an application, we'll store those in S3 and we'll manage the deployment of a new version of an application onto those containers in the running environment without any downtime. And we'll come on to showing you how that's achieved in a moment. So how do you create an app for AWS Elastic Beanstalk? Well, you do it exactly the same way as you do any other application you deploy. So whether it be a Java, a .NET, PHP or Python application, there really is no difference. There's no dependencies on AWS inherent for a Beanstalk deployment. So this is an example of that in action. So I can deploy an application locally on my local development machine, and I can upload that source application package into Beanstalk, run it in Beanstalk, and I can take that same package, download it again, and execute it locally. There is no changes required to deploy an application into the Beanstalk. You can, of course, leverage AWS services in your applications. That's a different matter. So you might want to use S3, for example, as a storage system. And that will work just as well locally, calling out to S3 as it would in Beanstalk, calling to S3 from the EC2 environment. And you package your application up as normal too. So if you're looking at a PHP application, you'll zip it up and pass it up to Beanstalk. A Java application would be a WAR web application resource file, and a Microsoft deployment would be a web deploy package. And we provide IDE plugins on the left and also Git integration on the right in order to do things like Git push into Beanstalk, and that you can do deployments direct from an IDE. So back to that idea of being a developer-centric kind of approach to managing a cloud infrastructure. From within something like Eclipse, you can do an automatic deployment. And I'll show you some screenshots of that in a second. So looking at the console and how you deploy an application to Beanstalk, within the AWS console, you choose your region that you wish to run a Beanstalk within. And then you can launch an environment or upload a new version. So shown here, I'm going to this little screen grab of uploading a new version. So I upload a new version, I'll choose my file, and I can choose whether I want to upload this version ready for deployment and not deploy it, or whether I want to deploy it to an existing environment after upload. So here, for example, I have two different Beanstalk environments, my deploy test and my production. And I can choose to upload this new version of the application and deploy it into either of those environments. I can also do these sorts of tasks from the command line. So just with any other part of AWS, you can call into the command line, check the application status, create a new application version, and so on. You can also use something we called EB, which is the Elastic Beanstalk wizard. It's a command line application that gives you some very simple controls and step through process to setting up an application. So you might choose to use EB init, which will guide you through the process, a little command line wizard for creating a beanstalk and uploading your application. You can start and stop applications and all the associated resources that are created under a beanstalk with EB. You can update an application and you request an application status. And back to that IDE integration, if you're using Eclipse, you can download the Eclipse plugin for Beanstalk, and you'll be able to then deploy an AWS Elastic Beanstalk application into a Tomcat container. So here Tomcat 6 and Tomcat 7 containers are supported. Choose to run on a server, choose the region I wish to deploy my application into, and I can choose to create a new application or choose an existing application to update and the environment I'm going to push into. My key pairs associated with the access for SSH for these machines, specify host names and so on and where I want them to go. And just in the same way, Visual Studio has a very similar set of wizards. So here, deploying my application using the publish function within Visual Studio, again choosing regions, choosing a beanstalk, and off we go, looking at the versioning of my application, the URL that my application is going to be published under, the container type. For example, here it's running on a micro instance 64-bit Windows server, which incidentally fits into our free tier. DB groups, security groups in this case for this application, getting back some review of some information for my deployment, and then I'm coming back here in my Visual Studio Explorer and showing that my environment is healthy. And here are some simple controls within Visual Studio to restart my app or rebuild the entire environment or terminate it and throw it all away. So with Beanstalk, from the developer's workbench, you can create a model template environment for running a scalable web app within AWS, and you never need to touch the underlying resources. If you're a Git user, you can do it from a Git push. So here is a git aws.push, counting the objects and pushing them out into my my PHP deployed test environment, and we're ready to go. We've updated my Beanstalk from a single command line git push. We'll talk about the abstraction away from the underlying resources, but if you so wish, you can go in and have a look at the settings that have been applied on this particular application. You can update those settings, ranging from the server type. So here, the micro instance is being used. But you may up this to a more production scale, medium or large EC2 instance. You can look at the load balancing, the auto scaling. So load balancing, how often it will check for health of instances and bring instances in and out of service on the load balancer. Auto scaling, so the group, how many instances you wish to start with to run your application and how many you wish it to grow to as a maximum. Look at the availability zones that you might want to run across. So here in case it's saying any two availability zones for a high availability deployment. And other things like databases, notifications, and then container types. So here, for example, if you're accessing AWS APIs such as S3 or DynamoDB, then you can provide your access keys and secret key. And in this case, this is a web app for using Java, looking at a JDBC connection string to your RDSs or so on. And again, container type, more settings here for Java, looking at heap sizes and so on. So you can get control of the underlying resources using the console. But of course, every single resource that's been created is a standard AWS resource. So if you so wish, or you need to go and SSH onto an instance, you can do so, and you can change that instance. If you wish, you can go into Elastic Load Balancer itself and change the settings directly. Or you can manage it all through the Elastic Beanstalk interface. So full admin access on the underlying resources. So from EC2 instances, the AMIs, the machine images that's being used, you can change the auto scaling properties and so on and so forth. So this is all about then taking application prototypes and a one-click deployment into that production-ready AWS infrastructure without the need to create those resources yourself or understand some of the finer semantics of how you do that within AWS and do that in a sophisticated, maybe mature operations environment. So taking your idea to your application, typically you're going to spend a lot of time doing what we call heavy lifting. So this is the configuration of resources, the management of operating systems and the environments that you want to create, the configurations of web apps or containers and so on. And you're going to spend a bit of time doing infrastructure, so setting up your DNS or setting up your load balancers and so on. So the other sort of aspects of creating an environment in the cloud. With Elastic Beanstalk, collapse all of that down, enable you to get to an idea quicker, or get your idea to an application quicker using Elastic Beanstalk, and not having to worry about the resources that are created. So putting this into context with a real customer example, I can't talk about the customer name, unfortunately, but it's a real story of significant scale. So this company was launching a new product into a brand new geography for them, and associated with that launch came a number of online applications, a marketing site, a whole suite of things to support this product launch. And it was a big build up to this launch at a particular hour on a particular day in a particular country. And when that hour came, their web applications crashed under exceptional demand. Effectively, they denial of service their existing data center. So they had this real problem, is that a massive marketing lead up to this product launch, and their web presence fell on its face. So they needed a fast deployment mechanism, and they really didn't care about the underlying infrastructure. What they wanted to know was that when they deployed their web application, is that it would scale, it would leverage cloud elastic properties, and they wouldn't have to configure anything other than the initial properties to start with. So they turned to Beanstalk and they redeployed their application from their existing data center. They tested for a brief period and then they put it into production, and it scaled seamlessly, restored the website, handled the load, and they haven't reverted. They now are using Beanstalk as a matter of course for such applications where they're supporting a marketing demand, a short spike in requirement, a very short lead time in getting their application into production. They don't have to worry about infrastructure or resources behind that. They can concentrate on the job in hand, which is creating the application and maintaining the user experience. So that's covered off a bit on Elastic Beanstalk, and we'll circle back on them both later. But CloudFormation at the opposite end of the spectrum, where you really want nitty-gritty control over everything that's created within the AWS environment. And CloudFormation is the framework that does that. So if you think about what happens under the covers of Elastic Beanstalk is making a series of calls into AWS to do things like creating security groups, creating auto-scaling policies, adding ELBs and instances behind those load balancers, installing some software and doing things like log consolidation. So it's executing a series of calls into AWS that marshal resource creation and then the subsequent configuration of those resources. And if you think about the wealth of resources that you have available to you in AWS, everything from compute, databases, the security groups, networking, middleware services like messaging and queuing and so on, CloudFormation exposes all of those things in a couple of ways, and it's actually a fundamental framework underneath the Elastic Beanstalk. So it provides a consistent scripting interface for creating and configuring AWS resources. So you might want to create an EC2 instance, you might want to create an auto-scaling group and configure that group. But there's also a framework for the lifecycle management of resources using scripts. So what happens if I have a resource that's defined via one of these scripts, and then I change that script, I update it? It's a framework that enables that resource to be updated in a graceful way. So if you look at the components behind CloudFormation, it starts off with a template. So this is a JSON formatted, if you like, script file that deals with things like parameter definition, things that drive a user-driven template. such as names of my databases or users to create on instances or software to install. Deals with the resource creation, so the creation of AWS components, if you like, such as EC2 instances or RDS databases, and deals with the configuration actions that I wish to apply against those resources. So it might be install software, or it might be set up an SQS queue, for example. And then that template is deployed into the CloudFormation framework, and the framework deals with what we call a stack creation, the stack updates, and any error detection and rollback that's required in the creation of a stack or the application of an update. And the resulting artifact is then what we call a stack, so configured AWS services. So this could be, in the classic case of the Beanstalk, an Elastic Load Balancer, an auto-scaling group, and some EC2 instances. Now the stack is service event aware in that the actions that you apply in the creation of a stack or the changes in that environment can feed back into CloudFormation and trigger actions within the template files. And it's also customizable. Once you've created a stack, you can of course go in and access the underlying resources and change them and modify them if you so wish. Now the error detection and rollback is an interesting point, is that if at any point in a stack creation a problem is detected, the default behavior of the CloudFormation is to roll back the creation of all resources and put you in a consistent known state. So you either know that your stack is working or it's rolled back and it's not. Now you can play with those, the error detection and the rollback properties, but fundamentally when you want to create a stack from a template, you want to know that it's created. That's the whole idea. So let's have a look at a bit of detail behind a template. So a couple of snippets here. Parameter definition, so the first item on that list on the left. So this is a snippet of a JSON template file where I've defined a parameter key name and I've typed string given in the description. Now when you create a stack in the AWS console, you'll see that parameter, my first point of the wizard that you'll see in CloudFormation, has my key name and my description and is asking for user input. So in this case it's asking for my EC2 key pair that I want to use to seed all the instances that might be created behind this stack. So you can take user input and you can use those parameters then in any other part of the script. You can then create resources. So here is an example of creating an RDS database. So we can see the resource section, and I'm calling the resource MyDB. So this RDS will be called MyDB as far as the stack is concerned. It's a type AWS RDS DB instance, which is a defined type, and you can find all of those types in our documentation. And I've set some initial properties here. So I've got a 5 gig allocated storage RDS instance. I want it to be on a small instance type. The engine I want to run is MySQL 5.5, and in this case I've hard-coded username and password, but these would typically be asked for from a parameter in the wizard or extracted from some file or so on. So that resource definition will create an RDS instance. Another snippet here is how do I actually then configure something on a machine. So if you look at some of the example templates, and I'll show you where you can get to those later, you'll find a whole series of actions. Commonly, obviously, we're going to go and install some software. So once we've created a load balancer or created some instances, we want to stick some software on those instances. So in this case, I'm using a config and I'm using yum on a Linux instance to install MySQL, Apache, and PHP. Okay, so that block under the yum there is going to go off and execute those commands as that instance is brought up. Another thing is I'm going to create or download some files here, and I'm going to stick some files in my HTML directory under my web server, and I'm going to get those files from S3. So I'm going to download a zip file from S3 and unpack it into my web directory. So I'm going to create, in essence, bootstrap some data onto the box so that when this server comes up, it's going to render some web pages back to my users immediately. So the benefit of templated environments is clearly that these are a procedural definition, right? And one of the things that our customers do is that they use or leverage the fact that it's JSON as well, is to create these programmatically. So they can create a a procedural definition of an environment from soup to nuts, and they can do it in code if they so wish. So they've got consistency in the generation of resources, and they don't need to introduce any human aspect into the creation of an environment. It's parameter driven, so you can create these things as dynamic entities or user driven templates. So anything that you would do in a typical scripting language is pretty much mappable into something you can do within CloudFormation. And you can drive the creation of resources, the naming of resources, etc., from your own environment, your own data, and your own logic. You can collaborate as well. So you can share templates just as easily as you can share a text file. So you can share these between teams as email, you can put them onto wikis, and you can create commonly used environment templates which you can pass around maybe between engineering teams, test teams, R&D teams, and so on. I want to recreate your environment. Well, here's my stack. Go take it from my template. And it creates a known configuration, so you can store this stack in source control, and obviously you can manage the changes to those stacks through versioning control as well. So this creates an interesting dynamic. So when you create an environment, you can version that environment, and you have a complete audit, of a procedural definition audit of that environment. Now in a classic data center, that's quite hard to achieve. This brings an interesting dynamic to some of the other sort of processes you have. Maybe if you're in a regulated environment, you have responsibilities under things like ISO 27001 potentially, or ITIL. Create some interesting positives in terms of being able to use the cloud and define things at such a meticulous level of detail. So I promised them a few case studies, and this is one of my favorites at the moment. So this is the Curiosity rover that's currently starting its journey on Mars, and it's to do with NASA TV. So you may or may not be familiar with the fact that the previous two rovers, we've used AWS services, or NASA have used AWS services to manage the image collection and stereo mapping from the cameras on the rovers to determine where that rover should go next, and we've used workflows and so on. Now that's still in place for those two rovers, and indeed Curiosity, but I wanted to focus on a different use case within AWS that NASA and JPL have used that incorporates CloudFormation, and it's to do with NASA TV. So as the rover was landing, it was broadcasting live images, and when it landed, live images to the world via NASA TV, which is a web broadcasting platform that they have. Now this was put the Curiosity landing put the greatest amount of demand that NASA have seen on their NASA TV infrastructure, or they anticipated it would, and indeed it did. So they needed a way in which they could manage the scale up and scale down of a pretty complicated and already in existence web TV and live streaming delivery platform, and they used CloudFormation as a fundamental part of that. So they had a CloudFormation template which defined a stack, which incorporated or defined a load balancer to front what they call secondary cache servers, generated about 100 NGIX secondary cache servers, and then 2 to 3 mid-tier cache servers behind the scenes, so different scale instances. So this was in essence their caching layer, which they had or they wished to deploy in different AWS regions and different AWS availability zones. And obviously they were piping in live content into this environment, and it was then served on these cache servers depending on where users came from a DNS level. So as the demand increased, as the rover landed and the first image was coming back, the demand spiked, and they manually used CloudFormation to initiate additional stacks to be deployed within an availability zone, indeed multiple availability zones across multiple regions. So once that stack was deployed, and they added more and more slices, if you like, of capacity to their delivery capability, the stack was also registering this as available load balancer in terms of the DNS provider they were using, which was Route 53. So the stack would deploy a whole host of 100+ servers, and then check that was operational, and then add it to their DNS routing, which would then do round robin and weighted routing into different availability zones depending on where that user was come from. And then when they were done, they could then just turn off stacks and take out whole slices of capacity. Okay. So a pretty significant stack in its own right that they were deploying, quite a complex rollout of cache servers. So where do you go to get more information on this? So the CloudFormation, we provide a set of templates that you can use to get started. So whether you want to look at a server template, so just setting up a particular type of Linux or Windows instance, look at maybe high availability configurations, how you create instances and load balancers across availability zones or auto-scaling groups. Got examples of relational database service configurations, DynamoDB and so on. We've also got complete open source stacks, so you might want to deploy a Joomla or a WordPress content management system, and you can choose stacks in this template library that would deploy it as a single instance, for example, with a local MySQL server, or as multiple instances with a high availability RDS server. And the templates can be used to fire those up, and you can click the launch stack and choose your region to deploy into, and it will launch you into the console and start you on the process. Or you can have a look at the text files that are the templates, and you can learn and take snippets and move from it. And we also provide a whole range of snippet libraries, so small pieces like how do you take a user input variable, how do you create a DynamoDB table, how do you integrate with the spot market, for example, to request an instance for a cluster compute. At the bottom there, we've got bees with machine guns template, so you can do spot instances behind load balancers to fire up a web testing attack, for example. But you can also download from this web page something called CloudFormer, which is our prototype at this point in time. It's an application that you can download and deploy to an EC2 instance inside your environment. And CloudFormer will then look at your environment, look at your servers. It will look at your IAM resources, your security groups, and so on and so forth. And it will generate you a template for your environment. Now, it doesn't look at what's running on machines and look at the installed software base, but it will give you a really good way to take an existing environment and create the snippets you require to then massage that into a cloud-formed environment. Now, CloudFormation, as I described before, it's comprehensive in terms of the services it supports. So all the ones you'd expect are manageable via CloudFormation scripts. But what I want to draw your attention to really is the fact that you can control Elastic Beanstalk as an AWS service from CloudFormation. Now this brings up an interesting sort of point. So previously we were talking about this sort of spectrum of either at the end of wanting a high-level shrink-wrapped way to deploy my app, and I don't care what's going on under the covers, so a very developer-centric view of the world, versus the fine-grained declarative view of the world, which is, sophisticated operations teams want fine-grained control and want to effectively source control their environment. Now, if CloudFormation can drive Elastic Beanstalk, you can bring these things together, so they work together. So you can have a highly controlled and documented, declaratively defined CloudFormation environment that encompasses the ability to have beanstalks running for development teams or engineering teams to be able to deploy applications and maintain high agility within, if you like, the safety net of a controlled operations team. So you can deploy developer sandboxes with production-ready infrastructure behind the scenes and maintain comprehensive control of all aspects of that infrastructure. So the best of two worlds. So that spectrum, if you like, collapses with the creation of these two tools and frameworks. So you can get started fast with Beanstalk, if you like. I like to call it controlling the chaos, really. Or you can take fine-grained control with CloudFormation, and you can create auditable environment specifications. So there's no other system that I know of where you can click a button and get a complete audit of your environment, but you can with AWS. So you can find out more. You can get started at both Elastic Beanstalk and CloudFormation web URLs. They do come under free tiers. So if you look at CloudFormation and Beanstalk, you're not charged for the use of either of those frameworks. You're only charged for the resources that are used under the covers. And if you're using things like micro instances or you're using low data volumes, you will fall within the free tier. So take a look at Amazon.com, aws.amazon.com. You look at the free tier and give AWS Beanstalk and CloudFormation a try.